بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is section 2.6 limits at infinity horizontal asymptotes. This is a very important section. We will learn how to find the horizontal asymptotes of a graph and how to find limits at infinity. The definition of when we say limit f of x when x approaches infinity equals L, we mean that when x becomes very large, f of x approaches L, come close to L, okay? For example, here, look to these three curves. This is the graph of f of x. And when as x approaches infinity, as x becomes very large, what happens to the function? It's approaching the line y equals capital L. Here, as x approaches infinity, the function comes closer to the line y equals capital L. Here, look to this graph. As x approaches infinity, now this function goes below and above the line y equals capital L, but every time it becomes closer from below and from above. So at the end, it becomes very close to the line capital L. So all of these three graphs means limit f of x as x approaches infinity is the line or is the number capital L. Also, when we say that limit f of x when x approaches negative infinity is capital L, we mean that when x is large, negative, takes sufficiently large negative numbers, f of x will become very close to the letter or the number capital L. Look here to these two graphs. X now goes in this direction. X goes to negative infinity. Okay, x approaches negative infinity, and the function, the graph, is approaching the line y equals L. Also here, as x approaches negative infinity, the function is raising and approaching the line y equals capital L. Now, if this happens, if the limit of f of x when x approaches infinity is L, or the limit when x approaches negative infinity, the limit of f of x is L, in any of these two cases, the line y equals to L is called a horizontal asymptote of the curve. So in all of these graphs, this line y equals to L is a horizontal asymptote. It's a horizontal asymptote. In all of these curves, y equals capital L is a horizontal asymptote. Let us look to the graph of tan inverse. And tan inverse is one of the important functions uh, here in this course. So this is the graph of tan inverse. Look, what do you see? If I ask you, what is the limit of tan inverse of x when x approaches infinity? What would be your answer? Okay, so x approaches infinity, tan inverse goes where? To the letter or the number pi over 2. And because of this, then the line y equals to pi over 2 is a horizontal asymptote. So this line y equals pi over 2 is a horizontal asymptote. Also, what is the limit of tan inverse x when x approaches negative infinity? So now look in this direction. Let x go to negative infinity. Where is the function going? The function is approaching negative pi over 2. So this is the limit of tan inverse when x approaches negative infinity. And because of this, the line y equals negative pi over 2 is another horizontal asymptote of the function. So tan inverse x has two horizontal asymptotes, pi over 2 and negative pi over 2. Look to this function, x squared minus 1 over x squared plus 1. What do you notice? What is the domain of this function? If I ask you, what is the domain of this function? Of course, you can see the domain from the graph. And if you look to the denominator here, x squared plus 1 will never be 0. X squared plus 1 is always a number that's greater than 0. In fact, it's greater than or equal to 1 because x squared, the smallest possible value of x squared is 0 because x squared is always positive. So x squared plus 1 has no real zeros, okay? Has no real zeros. As a real number, it's always greater than or equal to 1. So the domain of this function is all real numbers, set of all real numbers from negative infinity to infinity. Look to the graph. If I ask you, what is the limit of y, this function, when x approaches infinity? What would be your answer? Okay, take x to infinity and look to the graph. It's approaching the number 1. Okay, and also limit y when x approaches negative infinity. X now approaches negative infinity. The function approaches what? Again, the number 1. So what is the horizontal asymptote? Y equals to 1 is a horizontal asymptote of this function. Find the infinite limits. Limits at infinity. Well, there is a difference between infinite limits and limits at infinity. This section, limits at infinity. So when he asks about limits at infinity, he is asking about limit x approaches positive or negative infinity. This is limits at infinity. But infinite limits, this means that the limit when x approaches a would be positive or negative infinity. So infinite limits, the limit itself is positive and negative infinity. And infinite limits will give you the equation of the vertical asymptotes. The vertical asymptotes here would be x equals to a. But here you will get the equations of the horizontal asymptotes. So the horizontal asymptotes when limits at infinity would be y equals to capital L or the number. So look here, what do you have? What do you have at negative 1? This is negative 1, okay? You can see that limit when x approaches negative 1 either from the right or from the left of this function is what? What is the limit when x approaches negative 1? It is infinity. So what does it mean? It means there is a vertical asymptote x equals to negative 1. So the line x equals to negative 1 is a vertical asymptote and asymptotes. He needs the asymptotes, okay? All right, this is negative 1. What else do we have? At 2, okay, at 2. What is the limit of f of x when x approaches 2, let us say from the right, okay? What is the limit when x approaches 2 from the right? X approaches 2 from the right, the graph goes where? To infinity. This means that the line x equals to 2 is a vertical asymptote. We can also notice that the limit of f of x when x approaches 2 from uh, the left, when x approaches 2 from the left, the graph goes to negative infinity. And this also gives that x equals to 2 is a vertical asymptote. So we have two vertical asymptotes, x equals to negative 1 and x equals to 2. So these are infinite limits. Now let us look to limits at infinity. Let us find the limit when x approaches infinity of this function. So x approaches infinity. X is going there. The function is going where? Approaching what? It's approaching this line. What is this line? 0 to 4. So it's approaching 4. So horizontal asymptote, we have a horizontal asymptote, y equals to 4. So the line, this line, y equals to 4, this line is a horizontal asymptote. All right. What about limit of f of x when x approaches negative infinity? Well, x approaches negative infinity, so we are in this direction now. X is going like this. The function is going, approaching which line? This line. This line, which is the line y equals to 2. So the function is approaching 2, and this means that the horizontal asymptote of this function is also y equals to 2. So there are two horizontal asymptotes of this function, y equals to 2 and y equals to 4, and two vertical asymptotes. Look also to the graph of 1 over x. Okay, this is the graph of 1 over x. What is the vertical asymptote? It is the line x equals to 0. So the vertical asymptote is the line x equals to 0. Why? Because the limit of f of x, which is 1 over x here, the limit of 1 over x, when x approaches 0 from the right, is what? Is infinity. And the limit of 1 over x when x approaches 0 from the left is what? Is negative infinity. So this proves that the line x equals to 0 is a vertical asymptote. So this is what? This is infinite limits. Limits at infinity, if you find the limit when x approaches infinity, you notice that 1 over x approaches 0. And when x approaches negative infinity, the function approaches also 0. So there is a horizontal asymptote of this function y over x, which is the line, the horizontal line y equals to 0, or the x-axis. So what happens if I ask you to find limit 1 over x to the power r? Notice that 1 over x to the power r can be written 1 over x to the power all to the power r. And to find the limit of 1 over x to the power r, or 1 over x all to the power r, you can, the limit can go inside this, as we inside the power, as we have seen the properties of the limit. Okay, so the limit can go inside the power. And what is limit 1 over x when x goes to infinity? We have seen that it is 0. So the answer would be 0 to the power r, or just 0. So in general, the limit of 1 over x to the power r, where r is positive, okay, positive rational number. So 1 over 2, 2 over 3, like this, or 4, 5, 6, 7. But if it is negative, the answer will not be 0. If r is negative, then notice that 1 over x to the power negative 2, for example, would be x to the power 2. And it would be in the numerator. It's not going to be in the denominator. So to keep it in the denominator, r has to be positive. Okay. So if r is positive, then limit 1 over xr would be 0 when x approaches infinity or negative infinity. Now let us learn how to evaluate the limits uh, uh, at infinity. Okay, limits at infinity. I'll give you an easy method to find this limit. Whenever you have limits x approaches infinity, limits at infinity, we deal with the highest power in the numerator and the highest power in the denominator immediately. So all the other powers are not really important comparing to the highest power, because when x goes to infinity, x squared dominates everything here. Okay, so you don't look to x or 2 when you have x squared in the numerator and also x squared in the denominator. So immediately this limit would be equal to this limit, and now you can cancel x squared with x squared, and the answer would be 3 over 5. So this limit is just 3 over 5. Well, there is another way mentioned in the book. This method is to divide the numerator and the denominator by the highest power in the numerator and the denominator. So the highest power here is x squared. Okay, so you divide the numerator and the denominator by x squared. And then you distribute. So 3x squared over x squared would be 3. Minus x over x squared would be 1 over x. Minus 2 over x squared. And in the denominator, 5x squared over x squared is 5. Plus 4x over x squared, 4 over x. X cancels with x squared and you have 4 over x. And here I have 1 over x squared. And now this limit, you can distribute the limit. So the limit of 3 is 3. The limit of negative 1 or the limit of 1 over x when x approaches infinity is 0, as we have seen. 1 over x, the limit is 0. 1 over infinity is 0. Also 1 over x to the power r, 2 over x squared, the limit is 0. So here 0, here 0. And the limit of 5 is 5. 4 over x, the limit when x approaches infinity is 0. The limit of 1 over x squared is 0. So the answer is 3 over 5. So we are using this fact that the limit of 1 over x to the power r when x approaches infinity is 0. 1 over x, 1 over x squared, or 4 over x, okay, it would be 4 times 0. So the limit would be 3 over 5. So you can use either this method or this method to find the limit. How to find the horizontal asymptote? The definition. What is the definition of the horizontal asymptote? We said if you find that limit of f of x when x approaches positive or negative infinity is L, then the line y equals L is horizontal asymptote. So this is the definition. So whenever he asks you about a horizontal asymptote, you need to find the limit of this function when x approaches infinity and when x approaches negative infinity, because it could have two horizontal asymptotes. All right. How to find the limit when x approaches infinity? I'll use the first method always, which I illustrated here. Okay, most of the time I'll use the first method. So look to the numerator. What is the highest power? Well, the highest power is 2x squared inside the square root. Okay, the one can be neglected. And here the highest power is 3x, and I can forget about the negative 5. Now, this is a square root of x squared. Well, square root of x squared is absolute value of x, and it could be positive or negative x. Okay, it depends if x is positive or x is negative. So absolute value of x, the definition says, as you all know, that it's x if x is positive and it's negative x if x is negative. So when x goes to infinity, is x here positive or negative? Of course, x is positive. So if x is positive, then we have square root of 2. Of course, square root of 2x squared, square root of 2 times the square root of x squared, which is x. Okay, let me write it in details. So I will write it limit x approaches infinity, square root of 2 times square root of x squared, which is absolute value of x, and here 3x. Then I will write it limit x goes to infinity of square root of 2 times x. And why it is x? Because x is positive. So you can say since x is positive. Now x cancels with x, and the answer would be square root of 2 over 3. So we have a horizontal asymptote, which is the line y equals square root of 2 over 3. This is a horizontal asymptote of this function. Well, we need to find the limit when x approaches negative infinity, because this function could have another vertical asymptote. Okay. How do we find the limit? We take the highest power in the numerator and the highest power in the denominator. Now, this is square root of 2, and the square root of x squared is absolute value of x. But x is going to negative infinity. So x is a very small number, small negative number, or large negative number. So a square root of 2 and absolute value of x in this case would be negative x because x is negative, since x is negative. Sorry, I'll change this 3. Okay. Now x cancels with x, and you will have limit when x approaches negative infinity of negative square root of 2 over 3, and that's just a number. So the limit is negative square root of 2 over 3. Again, I have problem with writing 3. All right. So what is the equation of the horizontal asymptote? Negative square root of 2 over 3 is a horizontal asymptote. So there are two horizontal asymptotes, one positive and one negative line of this function. Compute this limit. Well, if I replace x by infinity here, the largest the largest term here is x squared. Square root of x squared is x because x is positive. So I'll have infinity minus infinity. Well, infinity minus infinity is indeterminate form, and I have to do something with it. Okay, like 0 over 0 in the limits, if you remember. So what should I do? I have square root minus x, so I'm thinking of multiplying by the conjugate. Okay, so what is the conjugate? It is square root of x squared plus 1 plus x over square root of x squared plus 1 plus x. Notice the denominator here is 1. So when I multiply these two fractions, okay, what do I get? This times this would be u minus v times u plus v will give you u square minus v square. So we will have x squared plus 1 minus x squared over square root of x squared plus 1 plus x. X squared cancels with x squared. And now if you replace x with infinity, you have 1 over, and here you have infinity plus infinity or infinity. 1 over infinity is always 0. So the limit of this is just 0. And this means that the line y equals to 0 is a horizontal asymptote for this function. How to evaluate this limit? Well, remember that I can take, this is the limit of tan inverse. Okay, remember tan inverse. What is the graph of tan inverse? Here, pi over 2 is a vertical asymptote, and here negative pi over 2 is a vertical asymptote, and the graph goes like this. So if I write it tan inverse and take the limit inside, okay, so what is the limit of this? 2, 1 minus 1 over 0, I'll get infinity, and 2 plus, okay, if you approach 2 from the right, this will give you positive number, so infinity. So in fact, you have tan inverse of infinity, okay. Well, what is tan inverse of infinity? When x approaches infinity, tan inverse approaches pi over 2. Maybe writing it or solving it like this is not really okay, because the limit can go inside if the limit of 1 over x minus 2 exists. But you can say, if you like, that this limit is exactly equal to the limit of tan inverse u, okay, when u approaches infinity for some u, where u is 1 over x minus 2. And you can solve it in another way. It would be more mathematical and acceptable. You can say that, or if you take u equals 1 over x minus 2. So as x approaches 2 from the right, we have u approaches infinity, because when x approaches 2 from the right, you 1 over 0, you will go to infinity. So we can say that the limit when x approaches 2 from the right of tan inverse 1 over x minus 2 is equal to the limit of tan inverse u when u approaches infinity. And now the answer is pi over 2 as we know. So writing it like this is more mathematical, better in my opinion, but the answer in both cases is pi over 2. Look now to the graph of e to the power x, the exponential function, the natural exponential function. If I ask you, what is the limit of e to the power x when x approaches infinity? What would be your answer? X approaches infinity. The function goes where? To infinity. What about the limit of e to the power x when x approaches negative infinity? Well, if x approaches negative infinity, the the function, the graph is approaching what? Zero. And that's why the line y equals to zero is a horizontal asymptote. So you could have infinite limits at infinity. What about this one? This is an example of infinite limits at infinity. What about limit sine x? Well, what happens to sine x when x approaches infinity? You know, sine 0 is 0, and the function goes like this. So it's oscillating between negative 1 and 1. And when x goes to infinity, it would be anywhere, somewhere between negative 1 and 1. So we don't really know what would be the limit of sine x when x approaches infinity because it oscillates between negative 1 and 1, keeps oscillating between negative 1 and 1. So this limit does not exist. What is limit x to the power 3 when x approaches infinity? So if you sketch the graph of x to the power 3, you will notice that when x approaches infinity, this will go to infinity. Okay, you can find it algebraically. If you replace x by infinity, infinity to the power 3 is infinity. While this one, if you write negative infinity to the power 3, then the minus sign comes out and infinity to the power 3 is infinity. So limit x to the power 3 when x approaches negative infinity is infinity. And you can see that also from the graph. When x approaches negative infinity, the function goes to negative infinity. So how to find the limit of this function when x approaches infinity? As usual, the highest power in the numerator is x to the power 3. The highest power in the denominator is negative x. This method works only when you have limits at infinity. Okay, so when you cancel, you get what? There is a negative sign, and x cubed over x is x squared. Now to find this limit, it is negative infinity to the power 2. Notice that the negative is outside. So infinity to the power 2 is infinity, and the limit would be negative infinity. So the limit of this function when x goes to infinity is negative infinity. This was the end of this section. Thank you very much.